All right, welcome to our first video review on related rates. We're going to try to break this up into a 2-night series so it's not super long. Tonight's video's goals will cover triangles, angles in a triangle, so where we use trigonometry, cylinders, and spheres. So how do we begin? Determine the rate you are trying to find. Then assign variables to things in the problem that are changing, hence the rate. Assign constants only, and let's be clear on this only, to things that are not changing. You can substitute a constant into your equation. And then obviously differentiate with respect to time. So question 1. A rocket rising vertically is tracked by a radar station that is on the ground 5 miles from the launch pad. How fast is the rocket rising when it is 4 miles high and its distance from the radar station is increasing at a rate of 2,000 miles per hour? All right, so again, our first step is going to be to identify everything. So we have this radar station, and a lot of times a picture is going to help, especially on these triangular type ones. So there's my rocket ship rising. I have this radar station, and they said that radar station is 5 miles away from the launch pad. So there's my launch pad. How fast is the rocket rising? So here's my question. Fast would be a rate. So how fast is this side rising when it is 4 miles high? And the distance from the radar station is increasing at a rate of 2,000 miles per hour. So here's the radar station, here's my rocket. I think they're telling me this side is 2,000 miles per hour. So you'll notice some things right off the bat. We have sides and we have rates. So one thing I want you to highlight for yourself is this 5 miles is never going to change. The radar station and the launch pad are never going to change. This is a constant. Okay, which means you know its rate. So I'm also going to slap some letters on here. I'm going to use ABC for the Pythagorean Theorem. I'm going to call this side AB, and obviously C is always my hypotenuse. So I can say A is 5, and then dA dt. If it's a constant, its rate is 0. This is a miles per hour, so this is dC dt. It's not actually C, it's dC dt. This 4 here is a length, so that's just my B value. And now I can easily go get my C value with the Pythagorean Theorem. So anytime I'm seeing a triangle, it's definitely all coming back to Pythagorean Theorem. So let's see, C equals, if I add that 1625, the square root of 41. So I can jot that down as well. All right, and again, like I just said, it's all coming back to the Pythagorean Theorem. I use that Pythagorean to find the missing side, and then I'll use that to take the derivative. So I'm going to say a squared plus b squared equals c squared, 2a dA dt plus 2b dB dt equals 2c dC dt. Now, since they all have a 2, it is fair to cross them all off. You're basically dividing everybody by 2. I know my a is 5, and it's a constant, so its derivative is 0. My b was 4. I'm looking for dB dt, how fast this rocket's rising. And then I know this side was, the rate was 2,000 times the square root of 41. Obviously, 5 times 0 is 0. I'm just going to divide out that 4. So I'd say dB dt is equal to 500 radical 41. Now, of course, we need some units, and it's a rate. That's the key word, so I'm going to say miles per hour. All right, example 2, really focusing in on these triangles today. The height of a triangle is decreasing, so there's a key word. This is a rate. Decreasing at a rate of 1 centimeter per minute, while the area, so now they're giving me a formula to use, is increasing at a rate of 2 centimeters squared per minute. I want you to take note of the units. Do you see how it's centimeters squared? If they didn't even tell you area, you should know that's the rate of area just based off those units. What is the rate the base of the triangle is changing when the height is 10 and the area is 100? All right, so again, let's get kind of a picture drawn out. Excuse me. Now, they don't call it a right triangle, so I'm going to stay away from that. And I'm going to draw in my height, which is always perpendicular to the base. All right, I know, let's see, the height is 10, they told us, and the area is 100. Okay, so I'm just using this last piece. When the height is 10, the area is 100. So obviously they're talking about area. Let's start with the area formula. 1/2 base times height. So I've got 100 equals 1/2 base times 10. Therefore, I can quickly say that my base is 20. Now, we know we're going to need that at some point. That's why I use that information to find it. So I'm kind of just going to cross it off and say, okay, I've used that. Let's use something else. They talked about the rate of area. So now I'm going to, again, go back to the area formula and take its derivative. Now, almost everybody has this down but a few people. And I keep saying, read it out loud to yourself. This says base times height. Times means multiplication, which is implying product rule. So when I take this product rule, I'm going to leave the 1/2 out front because that's not involved, and I'm going to just do the product rule between the two variables. So I'm going to say first times the derivative of the second plus the second times the derivative of the first. Okay, now you can distribute the 1/2 in or leave it there for the time being. I'm probably going to leave it for a few minutes and plug everybody in. All right, now what else do I know? The height is decreasing at a rate of 1 centimeter. Decreasing being key, meaning that height is going to be negative. And they gave me the ADT was increasing at a positive 2. We already know the base is 20. I know the height is 10, and the question then was find the rate and change of the height, which is my it was find the rate and change of the base, which is my dB dt. So now, again, we have everything we need. We just have to carefully plug in and chug here appropriately. So let's see. I'm going to keep this 2. I'm going to keep this 1/2. This is negative 20 plus 10 dB dt. Okay. Now, one easy way to get rid of this 1/2 is just to multiply both sides by 2, so that eliminates that. I don't really need to distribute it. So I have negative 20 plus 10 dB dt. Order of operations, obviously this dB dt is attached to this 10, so I cannot add these two together. I'm just going to move over that 20. So I'm going to get 24 equals 10 dB dt. And then finally I can say 24 over 10, which is 12 over 5, equals dB dt. Now again, let's assign some units. It's not area, so nothing is going to be squared. We're just going to say, oops, this is centimeters per minute. And I can say it's increasing because my rate is positive. All right, let's tackle a third type here. We did change the shape to a snowball. A snowball is in the shape of a sphere. So again, right off the bat, you've got to know your formulas. I'm assuming Pythagorean Theorem and area of a triangle are down. Sphere, again, is a nice geometry one. Our volume of a sphere and our surface area are the two we have to know. So I'm going to put SV for a sphere's volume is 4/3 pi r cubed. Maybe think of it as three-dimensional, so r cubed. And its surface area is super easy to remember because it's just the derivative of the volume. So if I derive that, I'm just going to get 4 pi r squared. So we do have to have those memorized. The volume is decreasing at a rate of 5 cubic inches per minute. Again, these units should give it away. Cubic meaning volume, per minute meaning the rate of volume. So I'm going to make a note. I know dV dt is negative 5 because it's decreasing. At the instant when the radius is 4, what is the rate and change of the surface area? What is the derivative of the surface area? Okay. Excuse me. So I always start with something they give me. They give me dV dt, so I should probably take the derivative of surface area. So I'm going to say dV dt equals 4 pi r squared. So I'm taking the derivative of surface area, dr dt. And I'm plugging in what I know. So dV dt is negative 5, so I'm using that. So I'm going to cross it off. 4 pi, they gave me r. I'm going to plug that in. 4 squared is 16 times dr dt. Now look how convenient that was. I was easily able to get dr dt. So I've got negative 5 equals 64 pi dr dt. So negative 4 over 64 pi equals dr dt. I just divided all that junk over. Okay, so now what is the rate of change of the surface area? Here's the question. I probably should go take its derivative. So I'm going to take that surface area and derive it. So my derivative of surface area is 8 pi r dr dt. And they were asking for the derivative of surface area, so hopefully I know everybody else. There's my 8, my pi, my radius was 4, and dr dt is what we just found, negative 5 over 64 pi. I can kill those pi's, 8 goes in there, so what does that leave me with? Negative 5 halves. Now again, we'll slap some units on there. It is the rate of change of the surface area. It's area. So what should your units have in them? Hopefully you're saying inches squared per minute. Oil is leaking from a pipeline on the surface of a lake and forms an oil slick whose volume increases at a rate. So they said volume and rate, and look at those units. So I know dV dt. Increasing would be a positive 200. The oil slick takes the form of a right circular cylinder. Both its radius and its height are changing with time. The instance when the radius is 50 and the height is 0.2, we read that as 2/10, so perhaps it's easier to call it 2 out of 10. The radius is increasing, so dr dt is positive 2.5. What is the rate and change? What is dh dt? What is the rate and change of the height? So wow, they gave us a lot of information that we have to come up with. Now the first thing they gave us was the shape, and they said it's a cylinder. Do you know the volume of a cylinder? Well, it's very simple to memorize. You just take the shape on the bottom, which is a circle, picture a soup can, so that's pi r squared, and now you want to fill the soup can up, so you have to multiply it by its height, and that is the volume of a soup can, of a cylinder. It's very simple. You start with a circle and you fill it up. All right, so they gave me dV dt, so clearly I want to derive this function. Now the key here, again, is they told us that they're changing with respect to time, so I know everybody gets a dr dt or d whatever dt. And again, when I read this out loud, it says pi r squared times h. So I have to use product rule as I go ahead and derive this. Now again, I'm going to leave the pi out front because the product is just between these two variables. So first derivative of the second plus second derivative of the first. And I'm going to plug in everybody that I can. Now note one quick mistake here. I think this radius was 50, not diameter. I apologize for that. So dV dt is 200 equals pi. My radius squared is going to be 50 squared times dh dt, which I do not know, plus my height, which is 2/10 times 2 times my radius of 50 times dr dt, which is 2.5. Now again, you can easily change that to a decimal. That's just 25 out of 10, or a fraction, I'm sorry. So I'm just going to carefully keep cleaning this up here. So let's see, that's 200 equals pi. It's 2,500. Plus, what can I eliminate here? I'm going to do some simple crossing off here. I'm going to say 10 goes into 50 5 times. 5 goes into 10 2 times. Then those 2's cancel. So I think I just get 50 over there, 50. And let's see. So I'm just going to keep sliding things up here. I am going to distribute that pi through. And then again, order of operations, I'm just going to take my 200, subtract over my 50 pi, and then divide by 2,500 pi to get dH dt. And I believe we were just finding the rate and change of the height, so that is going to be centimeters per minute. All right, so we've got a camera on the ground 300 meters away from a launch pad, records the hot air balloon rising at a rate of 10 centimeters per second. So again, I think this is one you can visually picture, so I'm going to draw something out to represent it. So here's my hot air balloon rising. I have a camera 300 meters away from a launch pad. Here's my camera, it's 300 meters away. It's rising at a rate of 10 meters per second. How fast is the camera's angle of elevation changing when the hot air balloon is 400 meters high? So I know this is 400, and here would be my angle of elevation. So this is a d theta dt question. Okay, now this is where all that trig comes back in. So the first thing I'm going to focus on is, again, Pythagorean theorem. They didn't mention area, so I'm not making that up. It's just back to Pythagorean theorem. And I can easily get the missing side. This is a 3, 4, 5 triangle, so hopefully you can do the math quickly and say, using Pythagorean, I can get that side to be 500. This camera and launch pad are not changing, so the rate of this side is 0. So again, I'm just going to slap some letters on it, A, B, C, so we're on the same page, and say dA dt equals 0. So here my B is 400, and this would be my dB dt. And my C is 500. I don't know dC dt at the moment. So anyway, the question is about this angle. So the rule for angles, I just want to start in our notebook, is you want to pick something if there is a constant. Okay? So this side is a constant, so I want to pick a trig function that uses A. So if you remember your SOHCAHTOA, it's going to be smart to pick somebody that uses A. So sine is probably going to be out. I'm in fact going to go with tangent. So I'm going to say the tangent of theta equals opposite over adjacent. So my opposite would be side B. My adjacent would be side A based off my picture. Okay, and now I can only plug in a constant. The only constant term I have is the adjacent side. So the tangent of theta equals B over 300. And again, that's only legal because it is a constant. Okay, so I'm just going to kind of take its derivative. So the derivative of tangent is secant squared theta d theta dt. Now if it helps you, it might be smart. This is really 1 over 300 times b, correct? Dividing by 300 is the same as multiplying by 1 over 300. So its derivative is 1 over 300 dB dt. It's just a coefficient. So now I'm going to plug in everything I can. So I'm going to need that picture on my screen. To get secant, you are literally taking the ratio of cosine and flipping it upside down. So cosine is adjacent over hypotenuse. That would be 300 over 500. And I'm going to flip it and square it. So 500 over 300 squared d theta dt equals 1 over 300. Now dB dt we knew. They told us dB dt, if I scroll back here, was 10. Okay, now I'm going to kill these zeros. That's legal, so it's really reducing and then squaring. So 5/3 becomes 25/9 d theta dt. And kill those zeros, equals 1 over 30, and then I'm just going to multiply by the reciprocal, so 9 over 25. 3 goes in there once, and in here 10 times, so I'm going to get 3 over 250. It was a degree, so it's radian per second.